Hi, welcome back to my channel Physics from 5 KSSM. Continue Chapter 4 Electromagnetism on topic 4.3 Transformer. What is transformer? The word transform means transformer can change something. You have discussed before about step-down transformer that used in mobile phone charger or step-up transformer that used in microwave oven. So what is the function of transformer in electrical appliances? Some of the electrical appliances required lower voltage, some required higher voltage. Thus, the function of transformer is to increase or decrease voltage of AC power supply so that it can fit the required value of voltage for the electrical appliances. What is working principle of transformer? That one we will discuss later. Look at activity 4.16. Aim is to gather information on working principle of simple transformer. This is one structure of transformer. The basic structure we can draw in this symbol for transformer. The primary circuit consists of primary coil. The number of turns is NP. As you can see here, the primary circuit is connected to AC power supply, AC voltage or alternating current. And the symbol here, the two parallel line, this is soft iron core. And then the second circuit is secondary circuit. Number of turns of the coil is NS. For the secondary circuit, it is connected to output terminal. So this output terminal can be connected to any resistor or any detector like galvanometer or CRO. So you can see this is the basic structure of simple transformer. What is the working principle of transformer? Let's watch this video to understand how transformer works. If you look at here, this is the primary coil. And this part is the secondary coil. The secondary coil and the primary coil is connected by a soft iron core. This is iron core. Primary coil is also known as input coil. Secondary coil is output coil. The soft iron core is cut into thin laminated layer, and then the layer will be glued together, so it becomes laminated soft iron core. What is the purpose of laminated soft iron core? This one we will discuss in the next part. Okay, how the current can be produced in the secondary coil. When current flow in the primary coil, magnetic field will be produced around the wire, and then the soft iron core will be magnetized. What happens to the magnetic field of the soft iron core? Due to the changing in the direction of current in the primary coil, the soft iron core will be magnetized in the direction and magnitude that keep changing. The changing in the magnetic field lines or the magnetic flux of the soft iron core is linked to the secondary coil. Or we can say that there is change in magnetic flux in the secondary coil. This will induce EMF in the secondary coil. When the circuit in secondary coil is complete, the current will flow in the secondary circuit. We call it secondary current or induced current. Thus, from here we can say that transformer works based on concept of electromagnetic induction. There are two types of transformer, step-up transformer and step-down transformer. For step-up transformer, number of turns of secondary coil is more than number of turns in the primary coil. Thus, the EMF induced in secondary coil is larger than EMF in the primary coil. The second one, step-down transformer. Number of turns of secondary coil is smaller than number of turns of primary coil. Thus, the induced EMF in the step-down transformer in the secondary circle, thus, the induced EMF in the secondary coil is smaller than the EMF in the primary coil. Let's discuss some questions. So for this topic of transformer, you need to recall what you have studied in lower form. Discussion. The type of power supply in the primary circuit, it is AC power supply. Okay, the type of power supply in primary circuit is AC power supply. The type of current in primary circuit, alternating current. Magnetic field produced by current in primary coil. Magnetic field that changes in magnitude and direction. As we know that for alternating current, AC current, direction keep changing every half cycle. Okay, so this one will cause the iron core to be magnetized in the direction and magnitude that keep changing. Okay, now, what is a function of soft iron core? The soft iron core will link the magnetic flux from the primary coil to the secondary coil. The phenomenon of electromagnetic induction in secondary coil, the changing of magnetic flux linkage in secondary coil will induce EMF in the secondary coil. Due to the use of soft iron core that link the magnetic flux from the primary coil to the secondary coil, thus it will cause change in magnetic flux in secondary coil. So this will induce EMF in secondary coil. The magnitude of voltage induced across the secondary coil. The magnitude or the voltage induced across secondary coil is directly proportional to number of turns of the coil. As example, in step-up transformer, to increase the secondary voltage produced, just increase the number of turns in the secondary coil. Now we want to relate between voltage across primary coil or input voltage, voltage across secondary coil or output voltage, and number of turns of primary coil, number of turns of secondary coil. So from here, we get Vs is directly proportional to Ns. Or we can say V is directly proportional to N. This one is one factor that discussed under topic of factor affecting induced EMF by referring to Faraday's law. So from here we get V divided by N is equals to constant. Okay, so the ratio of Vs over Ns is equals to Vp over Np. By rearrange this formula, thus we get this relationship. Vs over Vp equals to Ns over Np. Thus, any calculation to determine one of the value, for example, to determine Vs, if given Ns, Np, and Vp, thus you just substitute the value in this formula to get the answer. Now let's look at structure of simple transformer. So this is simple transformer. It consists of soft iron core, primary coil, secondary coil. Okay. For the primary coil, there is a power supply, AC power supply, and then for the output here, or the secondary coil, it will be connected to any load or resistor or any detector like galvanometer. Okay, so we can draw in the circuit. This is the electric symbol. So you can see just now this drawing represent the transformer. Okay, for step down transformer, we also discussed that NS less than MP, thus VS less than VP. Step up transformer, NS more than MP, thus VS more than VP. Okay, let's look at how induced EMF is produced in the secondary coil. Okay, first of all, let's look at the primary circuit. For the primary circuit, there is an alternating current power supply. So what happened? Let's say for the first cycle current flow, this is AC power supply. We can see the direction of current keep changing every half cycle. So let's say the primary current flow in this direction. So it will cause the magnetic flux for the soft iron core to be magnetized in one direction. Okay, it will be magnetized in one direction. So what happened next? If direction of current suddenly reverse, okay, from here, what happens to the magnetic field? The soft iron core will be demagnetized and then magnetized again in opposite direction. Okay, so the soft iron core will experience change in magnetic flux. Okay, look at here. AC power supply produces an AC current in the primary coil. The alternating current produces magnetic field that changes in magnitude and direction. So you can see from this graph also, we can see the current magnitude changing, direction changing. Okay. Next, the magnetic flux from the primary coil link to the secondary coil through the soft iron core. The changing magnetic field induces alternating voltage across secondary coil. Thus, induced current will flow in this external circuit or output circuit here. If you look at the basic structure of transformer, we can see there are so many ways of the transformer to experience energy loss. Okay, before that, let's look at the meaning of word ideal transformer. What is ideal transformer? Figure here shows an electrical equipment connected to output terminal of transformer. Let's say this part connect to any electrical equipment. Transformer receive input power from power supply and supplies the output power to electrical equipment. Therefore, electrical energy transferred from the primary circuit to secondary circuit. So from here you can see this is input power and then it will produce output power here. A transformer that is in operation experiences loss of energy. Therefore, output power is less than input power. So, this one measure the efficiency of the transformer. The symbol is this one. Not this one. Okay. So defined as efficiency equals to output power divided by input power times 100%. Let's look at the primary circuit. The current that flowing is IP. The voltage is VP. Thus, the input power is equals to VP IP. It coming from the formula of power P equals to VI. For the secondary circuit, or the output power is equals to VS IS. Because the secondary current flow and the voltage produced here or induced here is Vs. So this one is input power, this is output power. Normally, there are energy loss as heat energy along the way. Thus, the input power normally is smaller than input power. So when this happens, efficiency becomes less than 100%. Okay. When we talk about ideal transformer, it's a transformer that does not experience any loss in energy. It is impossible, isn't it? Okay, so if no energy loss, we can say efficiency is 100%, or power input equals to power input, or the power that supplied here or input here equals to power that output here. Okay, so efficiency 100%, or we can say in other words, this is a perfect transformer. From the formula of efficiency, output power divided by input power times 100%, or we can write this way. Therefore, we can say that output power equals to input power. So you can see from here, efficiency 100%. So we get PO equals to PI. Okay. So PO is the output part, PI is the input part, or we can write something like this. VPIP equals to VSIS. So this relationship we just can apply when mention ideal transformer. If we rearrange, we can get VP over VS equals to IS over IP. So you can see the relationship between VS and IS. The higher the induced EMF in secondary coil, the smaller the current in the secondary coil. Okay, let's look at how to increase efficiency of a transformer. As we discussed before, transformer become less efficient due to energy loss in form of heat energy. So how to increase efficiency of transformer? Before that, let's look at the causes of energy loss in transformer. Okay, what causes energy loss in transformer? First, we have resistance of the coil. As you can see, the coil is using very long wire. The primary and secondary coil consists of wires that are very long. As we discussed before, resistance is directly proportional to length of wire. So when the wire is very long, meaning resistance is very high. Okay, so when current flows in the coil which have resistance, heating of the wires occur. So heating will cause heat energy to be released. So this heat energy is wasted energy. Second is eddy currents. The changing magnetic field induces eddy current in iron core. Eddy currents heats up the iron core. The hot iron core releases heat energy to surrounding. We discussed that in the primary coil, alternating current flow direction keep changing every half cycle. So the change in the direction of current will cause the iron core to be magnetized in magnitude and direction, which is keep changing also. So what happens to the iron core? There is change in magnetic flux in the iron core itself. So the change in magnetic flux in the iron core, this one will induce a small value of EMF in the iron core that causes current to be produced in iron core. The small current is known as eddy current. Eddy current will cause the iron core to be heated up or become hot. Thus, the heat energy will be released to surrounding. So this is one more ways of energy loss to surrounding. Next is hysteresis loss. As we discussed earlier also, when the direction of current keep changing, the iron core will be magnetized in the direction that always keep changing. Okay, so this one will cause the iron core to be magnetized and demagnetized continuously by changing magnetic field. The energy supplied for magnetization is not fully recovered during demagnetization. Okay, So there must be work done for the process of magnetization and demagnetization. Okay, so this one also will cause energy loss in form of heat energy. Next is leakage of magnetic flux. The iron core will link the magnetic flux from the primary coil to the secondary coil. If we look at the basic structure of the transformer, this is the primary coil, this is the secondary coil. So when current flow in the primary coil, it will cause the iron core to be magnetized. So, of course, there will be flux line. Some of the flux line does not link to the secondary coil. There's some of it leak out. So once it leak out, the amount of the magnetic flux that link to secondary coil will become less. Thus, the magnitude of induced EMF also reduce. So this one we call it energy loss due to flux leakage. Okay. So there are 4 ways that causes of energy loss: resistance of the coil, eddy current, hysteresis loss, and leakage of magnetic flux. Let's look at the method how to overcome this situation. Okay, for the causes of energy loss, resistance of wire or resistance of coil, of course we need a longer wire. So in order to reduce resistance of the longer wire, use thicker wire by using this relationship. Resistance is directly proportional to 1 over cross-sectional area of wire. The thicker the wire, the smaller the resistance of the coil. How to overcome eddy current? Use laminated soft iron core. Instead of using 1 block of soft iron core, cut it to thinner pieces and then glue them together so it becomes laminated soft iron core. So laminated iron core will have resistance which is higher than 1 block of iron core. So when resistance is higher, current will become smaller. Or induced current in the iron core, or we call it eddy current, become smaller. Hysteresis, instead of using iron core, use soft iron core. Soft iron core requires smaller work done for the process of magnetization and demagnetization. Next, leakage of magnetic flux. As we discussed before, if we have this structure for the iron core which is separated, so some of the flux line might leak out. So this is less efficient of arrangement. So we can suggest more efficient arrangement. For example, we can use this shape. So what we do, this is the primary coil. So on top of the secondary coil, wound secondary coil on it. Okay, so this one will cause the flux line from the primary coil automatically will be linked to the secondary coil. So this is better than this one. Okay, so this is to overcome leakage of magnetic flux. So this one is better for you all to understand because this one can come out in essay, either section B or section C. Alright, just now we discussed about eddy current. For the case of transformer, eddy current will cause energy loss. But in some cases, eddy current can be beneficial. For example, in the case of induction cooker. So look at the figure here, shows a high frequency alternating current in coil producing a magnetic field that changes with high frequency. This magnetic field induces eddy current at the base of the pan. Eddy current heat up the pan, the base of the pan. Okay, you can see here. This is the pan, the base part here. Normally for the base part, it must be ferromagnetic material. Okay, so this is the coil. When current flow in this coil, it will be magnetized. So what happens? It will also induce eddy current at the base of the pan. Thus, eddy current heat up the base of the pan. So this is the beneficial part of the eddy current. Not all the material of the pan, okay, can be heated up by using eddy current. Okay, it's just limited to the material which is related to ferromagnetic material. Uses of transformers in daily life. Transformer has a wide range of uses. The following are some examples of machines that use step-down transformers and step-up transformers. For example, step-down to decrease voltage. Notebook computer charger, photocopy machine, and welding machine. For step-up transformer to increase voltage of AC power supply, microwave oven, defibrillator, X-ray machine, and many more. You can look at about the electrical appliances that using transformers. Okay, of course, the electrical appliances that using a smaller voltage or larger voltage as our household voltage. Okay, next we look at the energy transmission and distribution. When we talk about transmission, is electricity that transmit through the cable wire. Okay, so means it refers to electricity that directed from power station, okay, to the power line. Okay, so at here, use at the substation, there will be step-up transformer. Okay, for example, produced at the power station is only 11 kilovolt. So by using step-up transformer, increase to 132 kilovolt. The purpose of using step-up transformer here, because Vs and Is is inversely proportional. So when transmit high voltage, secondary current is smaller. Thus, it can reduce power loss. Power loss depends on I squared. Okay. So what happened next? The high voltage transmit will reach a main substation where it will supply voltage to heavy industries, for example. So from 132 kilovolt need to be stepped down here. Okay. So the rest all is step down transformer depending on the value of voltage required. So this part transmission is from the power station to the power line or transmission cable. Distribution is from the power line to the area or to the point where requires the voltage to be distributed. Okay, let's look at one example for calculation problem. Example 1. So this is the transformer. You can see NP. This is VP. You can see from here. This is VP. Okay. And then this one is VS, NP, and S. And then this is the electronic equipment label. Calculate number of turns of primary coil. So we use the relationship here. VS over VP equals to NS over NP. So you just substitute the value of VS, VP, and NS. So you will get NP equals to 800. Output power 27 watt. From the formula of output power equals to VSIS. Output is secondary circuit. So we get VSIS equals to 27 watt. So calculate for IS, we get 1.5 ampere. And then C, calculate current in primary. Primary is the input part. Is VPIP. Okay, so VPIP equals to VSIS. If we assume this is an ideal transformer, then we can apply this relationship. The word ideal is here. So we calculate for IP, we get 0.1125 ampere. For the electrical energy transmission and distribution, I have discussed before that transmission involving the power or the voltage from the power station to the power line or transmission cable. Distribution is where the voltage will be distributed to the point depending on the value of the voltage required. Okay, so during distribution of electrical energy, step-down transformer are used to decrease voltage in the power cable in stages to a suitable value for industrial and residential consumers. So you can see here, this one step-up transformer from the power plant to the transmission cable, and then here all are step-down transformer. Okay. Okay, next look at formative practice 4.3. A step-down transformer is connected to AC current power supply. Explain working principle of the transformer. Okay, first of all, we look at the primary coil. So what we can say, AC voltage produces alternating current in primary coil. Alternating current produces changing in magnetic field. Magnetic field is linked to the secondary coil through soft iron core. The changing in magnetic field induces AC voltage in secondary coil. Number of turns of secondary coil is less than number of turns of primary coil. Therefore, the transformer step down voltage. Okay. So this is how it works. Okay. A pupil collects the following information on transformer: primary voltage, primary current, secondary voltage, and secondary current. Calculate efficiency. Formula: output power divided by input power times 100%. So we have VSIS divided by VPIP times 100%. So you just substitute into the formula all the values here. So we'll get 96%. Okay. So this is not an ideal transformer because the efficiency is less than 100%. Explain two factors that cause transformer to be non-ideal. So you discuss the factors that cause energy loss. Resistance of the coil. Okay. Causes heating of the coil when current flowing through it. Hysteresis loss causes magnetization and demagnetization of soft iron core. Number 3, explain how induction cooker can heat up food in steel pot. The alternating current in coil produces changing in magnetic field. Okay, the changing magnetic field induces eddy current in the base of the pot. The eddy current flows along a path of low resistance and heats up the base of the pot. So this is how it works. Okay, next. Transformers are used in electrical energy transmission of distribution system. Transmission, the transformer is step-up transformer because from power plant to the transmission cable. At the distribution substation, step-down transformer to decrease the voltage transmit to the required value of the points or station. Okay. Okay, that's all our class today. Okay, you can do more research on this so that you can understand better. That's all for now. Thank you for watching. Bye.